Good morning, everyone. Afternoon, good evening, whatever. It's time to start talking about calculus by rule. So none of this first principles formula stuff. Let's do the actual easy, the easy way of doing it. So now there are two ways to express the derivative. So there's the function notation way, which is f dash x. But then there's also this other thing called dy dx. So if you're in function notation and you start with f of x and I ask you to find the derivative, you're going to get f dash x. If you start with y equals and I ask you to differentiate it, you're going to get dy dx. Now this notation was created because it used to use a Greek letter that looked like the letter D, and so it was that Greek letter Y, Greek letter X, and eventually we just got lazy and started calling it dy dx. Now, y equals ax squared plus bx plus c. Now, if I want to find the derivative of this with first principles, it's going to be a pain. However, by differentiating by rule, I can work out very easily, very quickly, that the derivative, so dy dx, is equal to that, 2ax plus b. What I want you to look at, and be careful about this, is what moved around and what changed between y and dy dx. Some things moved and some things disappeared. So, all right, big deal. First things first, there's no c. The c is gone. Cool. So the c doesn't change what the derivative is. Cool. Excellent observation. Instead of x squared, it's 2x. So there we go. The exponent changed to a coefficient. This 2 came down the front. So what's the new power of the x in the derivative? It's 1. So is that higher or lower? Well, it's lower. So if this one went from 2 to 1, what happened to the x here? What's the power there? It's 1. So what did the power of it become here? Well, it became x to the 0, and as we all remember from our indices laws, x to the 0 is 1. So we just get rid of it. And then because c had no x's at all, it just gets dropped off. So this is the basic concept of the rule. If y equals ax to the n, dy dx equals nax n minus 1. I take the power, I drop it down the front, and I subtract 1 from the power. And I do that for every term in the equation. I take the 1 down the front, drop it down, subtract 1 from the power to become 0. 1 times b is just b. C has no x, we drop it off. So for example, if I do y equals x squared plus 5x plus 6, what is dy dx? Well, take the 2, put it down the front, subtract 1 from the power, left with x to the 1. Take the power, drop down the front, so it's 5 times 1. Subtract 1 from the power, x to the 0, it's just 1. Oh, sorry, 0, yep, so we leave it. And then the 6 goes away. So the derivative is able to quickly be generated by doing this. And of course, it works with even longer ones as well. So if I do, we'll go 2x cubed plus 4x squared minus 9x plus 12. All right, very quickly we can get dy dx is 6x squared plus 8x minus 9. And until you start getting into the weird and wonderful equations, this rule works. The only times this doesn't work is when I start asking you to do differentiations of things like y equals that. But that's just cruel and unusual. So as long as you can express what's going on in index form using only indices, you can do dy dx to almost any equation or function. Even that. I can dy dx that, no problem. How? Write that in index form using indices. X to the minus 1. So that becomes x to the minus 1. Well, if I do dy dx on it, minus 1 comes down the front, and then I subtract 1 from the power. How can I write that using only positive indices? Well, if that becomes that, then this can become x squared. The thing to notice with all of these is that the derivative is always 1 power lower than the original function. So minus 1 becomes minus 2. The derivative of a quadratic is a linear equation. The derivative of a linear equation is a straight line. A cubic becomes a quadratic, and so forth. And then, of course, we can use our knowledge of the derivative or the derivative equation to do these problem solvings. If I wanted to find the axis of symmetry on a quadratic, what's the formula for that? The axis of symmetry on a quadratic. Negative b over 2a. All right. And what do we know when we have a derivative equation? Where is the turning point going to be? It's when the gradient is equal to 0. So if I have a derivative equation and I make that derivative equation equal to 0, then you can prove this cool little thing. TP when dy dx equals 0. 0 equals 2ax plus b. Solve for x. So this whole time that you've been using that, you've actually been using calculus. Because that's where we got it from. Neat. So, find the turning point. Minus 3x squared plus 4x minus 9. First things first. Dy dx. Then dy dx equals 0. 0 equals dy dx. X equals... Keep going. So what I want you to do is I want you to type it into the chat, but don't send it. All right? I want to give everyone 60 seconds. And then when I say now, everyone is going to type it all at once. Everyone's going to hit enter and everyone's going to go in all at the same time. So what I want is you to type out what you think dy dx is. Type that out. Don't hit submit or enter yet. Leave it for about 60 seconds. And then we will all submit at the same time. And hit enter. All right. Minus 6x plus 4, if that's what you put in, groovy. So it's minus 6x plus 4. And now from there, 0 equals minus 6x plus 4. So that means the answer is going to be add 6x to both sides. So x is equal to 4 over 6, or 2/3. All right. So those of you who said negative 4 over 6, you're also wrong. All right, because that minus 6x will go over there, become a positive. So I'll get 6x equals 4. That means x is equal to 4 over 6, or 2 over 3. And then from there, you would find the other part of it. Because remember, all this tells us is the x value. All right? All this does is tell us the x value of the turning point. So it would be minus 3 bracket 2 over 3 squared plus 4 times 2 over 3 minus 9. So it's minus 3 times 4 over 9. 4 times 2 over 3, so that's 12, that's 14 over 3. Minus 9, which is 27 over 3. Minus 3 times 4 over 9 is minus 12 over 9. Plus 14 over 3 minus 27 over 3. That's minus 12 over 9. Minus 13 over 3. Because 14 minus 27 is minus 13. Times top and bottom by 3 to get into thirds. So that's minus 12 over 9 minus 39 over 9. So that's negative 51 over 9. So the turning point is 2 over 3, 51 over 9. And by hand, you have just found the turning point using calculus. Now, obviously, we had that formula. We had negative b over 2a to get the axis of symmetry to do this same thing. However, where that falls down is obviously when we are working with larger things. All right, so if we start going into our cubics, our quartics, and we start talking about the derivative of those, well, then you need to be able to do this properly. One more? Yeah, we'll do one more. All right. Let's do you want to do a quadratic or a cubic? All right, cubic it is. All right. First things first, I need to make sure I'm actually gonna give you guys one that actually can be done. Because remember the last time I did this, we gave you guys one that couldn't be done. Can I please get a number between 1 and 5? All right. 4 and 3. Beautiful. All right. X cubed minus 2x squared minus 11x plus 12. So same thing as before. I want you to type what you think dy dx is. Type it in. Don't send it until I say so. I have a handy dandy timer on my desk, which is the timer for the recording, so I can keep track of the minute from there. Thirty more seconds. Hit enter. Three x squared minus 4x minus 11. Beautiful. There's our derivative. All it means is you're paying the most attention, the closest attention, or you have the fastest internet, so my voice reaches you first. All right. So. At the end of the day, you have the right answer. So that's what's important. So from here, we now need to go dy dx is equal to 0. 3x squared minus 4x minus 11. How do I solve that? Remember, I want solutions. I don't want factorizing. I want the actual solutions. What should I be using? I should be using the quad formula. So I'm not going to ask you guys to do this and type that in there because it's going to look a little messy. So it's going to be negative b plus minus the square root of delta divided by 2a. So in this case here, I have, yeah, I know. There's b and there's c. So it's negative of negative 4. What is negative of negative 4? Plus 4. Plus minus the square root of 16 minus 4 times 3 times minus 11. So that is minus 4 times 3 is minus 12. Minus 12 times minus 11 is plus 132. All divided by 2 times 3, which is 6. So, x equals 2 over 3 plus minus the square root of 148 over 6. Square root of 148, is that something that we can just do? But what is it? What can we simplify the square root of 148 to? First things first, is it divisible by 4? All right, so as an aside over here, 148, that'll break down into 4 times 37. So that'll be 2 root 37. 37 is a prime. We can't do anything else with it. So that means that 2 goes out there, cancels, and that will become a 3, and that will become a 1. And that will be 37. So x is equal to 2 plus minus the square root of 37 all over 3. And those are your points that you will then need to take back to your original cubic and put them in. You want to know the quickest way to do it in your CAS? Yeah, you guys probably want to know the quickest way to do it in your CAS. All right, CAS on. All right, so what we're going to do is we are going to, using our CAS under Math 2, we have this lovely second column, third one down, we have this d dx. And what we're going to do is we're going to find d dx of our x cubed minus 2x squared minus 11x plus 12 comes out with that. Now what I'm going to do is I'm going to also define f of x as being that. And what I can also do is define it first and then just do this. Because remember, you've defined what f of x is, so you've got that. So now I can go solve comma x, 11 equals 0 comma x, and it gets me my, oh look, they look familiar. Now what I can do is I can go f bracket and it will spit out an answer for me. Unfortunately, the easiest way to represent it is literally how I've done it there, or how the CAS has done it there. There is no nice, quick, easy way to represent it. And then you would repeat the process. With the other one. So grab the opposite, pop it in, and then tap it, highlight it, convert it to a decimal. So there you go, you've got the first one, which is negative 1.361 and 20.745, and then the other one is 2.69 comma negative 12.597, and those would be your exact locations of your turning points, give or take, because obviously that is the actual answer and we don't want to write all that, so we're going to decimalize it and shorten it to a couple of decimal places. I'm not going to ask you to do that by hand, as in all this other stuff with the CAS. That's what your CAS is for, to do these sort of number crunchy calculations. Unless, of course, I knew it could be done by hand, in which case, watch out. And that, in 29 minutes, is differentiation by rule.